righty, so synthesis reaction is what we're going to talk about today. We're going to talk about synthesis and decomposition reactions, okay? I will tell you there are 5 different reaction types. If you know synthesis, decomp, single, double, and combustion. A single replacement reaction is known as a displacement reaction, okay? You see that term somewhere, especially in older chemistry books or older things, a single replacement known as a displacement. A double replacement is known as a metathesis reaction. Synthesis reactions can be known as a lot of different things, okay? Combination reactions, composition reactions are typically the 2 of the most common names other than synthesis reactions, okay? Composition, synthesis are all the same thing. A synthesis reaction, when you synthesize something, you put things together. You put things together. So also known as a combination reaction in which 2 or more substances combine to form a new compound. A key thing in a synthesis reaction, okay, is there is only one product of a synthesis reaction, okay? Today we're going to talk about synthesis and decomp. Tomorrow we're going to talk about single and double, okay? And on Wednesday we're going to talk about combustion reactions. You're going to be asked to classify reactions, not today, but Thursday, okay? Wednesday and Thursday and Friday. The biggest key to look out for, I'll remind you again, if there's only one product, it is a synthesis reaction. Who had a question? Oh, yeah. I'll put it back up, yes. A synthesis reaction, there's only one product. Now, there's a lot of different ways this can be, okay? You can add 2 elements and make a compound. So you can break that down into a metal plus a non-metal. So if you want to make a binary ionic compound, your metal plus your element. Now notice, this is your non-metal, okay? A metal plus a non-metal yields an ionic compound. The Cl2 because it is diatomic. Why is it not NaCl2 in the products? But why is it not NaCl2? This is a common mistake. Most people want to write NaCl2 because it's Na plus Cl2. What is the formula of sodium chloride? You still cross your charges, okay? Na has a plus, Cl has a minus, okay? So the coefficients and the bottom numbers really have nothing to do with what the formula is over here, okay? It could be a non-metal plus a non-metal. So this actually has mistakes. This is say S8. S8 plus O2 makes SO2. So a key thing here is if you're making a non-metal and a metal together, you cross your charges and you follow those rules, okay? A metal and non-metal, you cross your charges and you follow those rules. In the binary covalent, if it's 2 non-metals together, you just pretty much just put something that goes together. I mean, for the purposes of this class, okay? 2 non-metals, you put things that go together. You make it something that's somewhat sensible. We'll work some more examples of this. I cannot stress enough that when you're going to ask me a question in this, synthesis and decomposition, while in some ways they're the easiest, they have the most rules, okay? They have the most rules. I'm going to ask you, the first question I'm going to ask you is, how would you describe this synthesis reaction? I'm going to ask you, is it an element, a compound, okay? If it's an element, is it a metal, a non-metal, or 2 non-metals? What about 2 metals? How come I don't have that on there? Why don't I have that on there? Why does it not say metal plus metal yields something? What? It can happen. It's very rare to happen. But most metals are unreactive, okay? And we know most metals don't react with each other, okay? Does a penny react in your pocket? No. A penny is 95% zinc and 5% copper. A penny is not pure copper, okay? So metals don't typically react with each other, okay? Metals typically don't react with each other. That's why it's not on there. So an element plus a compound, In general, this section right here, element plus a compound, use a compound, are already balanced, okay? In general, that's a very good way to look at that. You just add them up. If you want, you're going to predict the products today. How many, you had 1 P over here, and you had 5 CLs, so that's what would be PCl5. That's an in general rule. A compound plus a compound. Now, this is the hardest one, and this really goes into decomposition. It's harder on the decomposition end, okay? A metal oxide, so that is any metal, oxygen, okay? So CaO, I think it's my example on there, plus CO2 yields a metal carbonate, okay? It could be MgO plus CO2 yields MgCO3. A non-metal oxide plus H2O. So give me an example of a non-metal oxide. That's going to be some other thing with oxygen, another non-metal with oxygen. Calcium's a metal. So the example of this one is SO3 plus H2O yields H2SO4. What about SO2 plus H2O? What would that make? H2O plus SO2. Sulfuric acid. In general, these are balanced also, okay? These are balanced also. These are balanced also. So ClO plus H2 plus, that's actually not a good, in general, balancing doesn't happen. You just add your O's, okay? Just add your O's. So ClO plus H2O would be HClO2, okay? HClO2, so that would be chlorous acid. A metal oxide plus water yields a metal hydroxide. CaO plus H2O yields CaOH2. Now, why is this just a 1 and a 1, and why is this 1 and 2? Because your cross charges, yes. You know that Ca has a 2+ charge. Oxygen, the oxide, has a 2- charge. Okay? So that they cancel out. That's a 1 to 1. But Ca has a +2. Hydroxide has a -1. So it makes a 2. You need 2 hydroxides to balance out that 2+. Metal oxide plus SO3. Once again, these are all compound plus a compound. Would make a metal sulfate. Decomposition reactions are when things break down. Now, notice this is the only one that only has 1 reactant. Synthesis only has 1 product. Decomposition only has 1 reactant. Examples, I got good news for this and bad news. If you can do a synthesis reaction, guess what? You should be able to do a decomposition reaction. Because they are identically backwards. Okay, they are identically backwards. If it goes together in a synthesis reaction, it breaks apart in a decomposition reaction. So you're going to see these rules here. Now, I have a few different ones on here. A metal chlorate is plus heat. Typically, that plus heat is not given, okay? Makes the metal chloride plus oxygen. Conversely, you could say a metal chloride plus oxygen makes a metal chlorate. Hydrogen peroxide breaks down into water and O2. Group 1 or 2 nitrate goes into a nitrite plus oxygen. Didn't we already have this one? On the synthesis half, okay? Does this happen naturally? Yes, it does. The metal carbonate. What is calcium carbonate? What's another name for calcium carbonate? Your earth science. What grade did you learn earth science? Who was your teacher for that? He would be very disappointed in you. Mr. Williams? I don't know. They searched it up. Calcium carbonate is another. It's also another name for chalk, but it's also another name for limestone. Okay, so remember we started talking about sinkholes and things like that. Sinkholes happen a lot of times, product after acid rain and things like that. That's because of this. Okay, because of that, it's calcium carbonate breaks down. It's also chalk, same stuff. Also same stuff. Magnesium hydroxide breaks down in, so a metal hydroxide, this is the reverse of what we saw. A metal oxide plus water makes a metal hydroxide. So the reverse of that is this. As is the same thing we saw, just the other way, I will tell you, and this is the point to make right now, the last bullet on there, H2O plus, or H2CO3 goes to H2O plus CO2. If you write H2CO3 on a chemical reaction, it's wrong. If you write H2CO3 on a chemical reaction, it's wrong. Carbonic acid naturally breaks down into H2O plus CO2. Okay? Carbonic acid naturally breaks down to H2O plus CO2. How do you know? That just happened. Carbonic acid just broke down into, exposed to natural elements, H2O plus CO2, the carbon dioxide release. Same thing with my soda. You heard the fizz? That's the carbonic acid naturally breaking down. This also naturally occurs in your bloodstream. You have H2CO3, you have carbonic acid in your blood, it naturally breaks down into H2O plus CO2. This is just the last one on there. That's just an extra example of that on there. So let's work some examples. I'm going to ask you to classify this and to predict the products, okay? Give me a second. All right, so our first example is going to say H2O yields. So I'm going to ask you to predict the products. I'm going to ask you to classify, predict, and balance. Okay? Classify, predict, and balance. And I put them in that order for a reason. Okay? And then we only got 2 options today. Tomorrow we'll add some other options to it. Okay? What type of reaction is this? Because I asked you to classify it first. What? Why? There's only one reactant, isn't there? So this is a decomposition reaction. Okay, this is and I'm just going to write decomp. That's fine. Okay. This is because there's only one reactant. Now, how is this going to break down? How would you expect H2O to break down? Anybody? No. Break down. If I put H2O2, what else would it break down into? What? H2 plus O2. To break down into, this is a binary compound, isn't it? A binary ionic compound. It's going to break down into its elements, okay? So it'll break down into hydrogen and oxygen. We know that hydrogen and oxygen are both diatomic. So that's 2s. And I would put a 2 in front of those 2 to balance it. Next one. NaCl plus O2. Synthesis or decomposition? Why? Yeah, that's my only option is, are there more than, right now, synthesis and decomposition, we know decomposition only has one reactant. So this is a synthesis reaction. What? Only to today, yes. So this is a synthesis reaction. Why is it synthesis reaction? They've only got 2 options. Synthesis and decomp, okay? And I know that decomp only has one reactant. This has 2 reactants, doesn't it? NaCl and O2. So for process elimination today, and we're still going to use this ruling tomorrow. That rule tomorrow, maybe a little bit more complicated, but still the same thing there, okay? Now, what is this going to combine to make? Keep in mind, in a synthesis reaction, there can only be one product. So what do you think it's going to make? Don't be scared to say something wrong. What do you know that has NaCl endo? Sodium chloride is a good option. Okay, sodium chloride is a very good option. That's an incorrect option, but in this case it would be wrong. Okay, it would actually make sodium chlorate. We knew from our decomposition rules. Go back. I can't stress you enough for these notes. I have you write all these notes and all those minute equations on there for a reason. Okay, we know that a metal chloride, a metal chlorate breaks down into the metal chloride plus oxygen, okay? So if this is the metal chloride, okay, then our product would be the metal chlorate. So it would be NaClO3. NaClO3. Chloride's a very good option. Very good. Just some rules of how things go together is the only reason why that was wrong. And to balance this, it would be 2, 3, 2. So just know when you have a metal chloride plus oxygen, it's going to make the chlorate, not the chloride. Next one. Let's go with Na2CO3. Synthesis or decomp? Decomp, why? There's only one. There's only one reaction. So this is a decomposition reaction. I can tell you a rule of thumb. Spelled that wrong. 95% of the time when you have CO3, or I tell 100% of the time when you have CO3, when you think CO3, think CO2. So it's going to make CO2. And what else? You know that a metal carbonate breaks down into carbon dioxide and what? Look at your notes if you don't know. A metal carbonate breaks down into carbon dioxide and what else? Not just the metal. The metal oxide. So sodium oxide, what is the formula of sodium oxide? What? Na2O. Na2O. Good job, Whitey. Na2O. Because sodium has a plus charge, oxygen has a 2 minus charge, okay? Is it balanced? Yes. A lot of the times, decompositions are already balanced, okay? A lot of times, decompositions are already balanced. If you two need to move, by all means, move where you can see better. I'm sorry. Na2O. Next one. Let's go with P4 plus O2. P4 plus O2. And once again, I'll remind you that it's P4 because phosphorus is a polyatomic element, and oxygen O2 because oxygen is one of your 7 diatomic elements. So, what is it? Synthesis, because there's more than one reactant. So that makes this a synthesis reaction. Someone give me a shot. What's the answer? What? Okay, it's a synthesis. Okay, so as a synthesis, let me back this question up before I ask the answer. Is it a, here's my question for you. Is it a element plus an element, a compound plus a compound, or an element plus a compound? It's an element plus an element, okay? It's an element plus an element. Now I can break this down again. Is this so element plus element has 2 options. Metal plus non-metal, or non-metal plus non-metal. Is it what? So non-metal plus non-metal. Remember what I told you about non-metal plus non-metal? Just put something together that only has the metal and the non-metal. I would take 22 different answers. Well, P4O2 I would not take because that's not reduced, okay? P2O, I take that. I take P2O. I would take or PO3 or P2O3 or PO2 or because we're not going to get into which one it makes, okay? I would take anything that has only P and O in it, okay? Anything has PO, I'd take P18O19.
Well,
P02, I'd take that too. Okay? There's some rules for that happens that's beyond the scope of this class, okay? So, any way you want to do it, I would take it. Now, what I would probably tell you to do, if I'm going to add carbon and oxygen, I'd probably make CO2, because we know that, okay? But I would take anything for that. So you give that a step. If it's a non-metal plus a non-metal, just give me something that's reduced, okay? Give me something that's reduced. I mean, if I was doing it, I'd probably do P2O. Got to be the easiest one to balance. Personally, what I'd probably do, because I'd probably just put a 2 there and be balanced the easiest, okay? But I would take anything. All right, let's see here. Let's do RB2O plus H2O. RB2O plus H2O. This is scribble right here in front of it. Rubidium oxide plus water. Sometimes people find it easier to say things aloud, okay, to themselves, not all 18 people talking at the same time. So our first question, synthesis or decomp? Synthesis, because there's more than one reactant. So it's a synthesis reaction. I'm going to go back and ask those same questions again. Element plus an element, or an element plus a compound, or plus a compound plus a compound? What? Compound plus a compound. Compound plus a compound. So now I'm going to go look at that section of my notes. This is a metal oxide, isn't it? Plus water. What's a metal oxide plus water make? Metal hydroxide. So my metal in this case is what? Rubidium. So rubidium hydroxide would be my compound. Rubidium hydroxide is RbOH. RbOH. And to balance this, I believe I'd put a 2 in front of this. Starting to make a little sense? I didn't say it was making sense. I said it's starting to make a little sense.
The first part was
NO2 plus H2O. Zariah. Synthesis or decomp? Got 50-50 chance. Synthesis. I'd say that's correct. Why is it a synthesis? I can rule out decomp because decomp only has one reactant. This has 2 reactants, okay? So it's a synthesis reaction. It's a synthesis reaction. What type of synthesis reaction is this? Compound. You're great. You're there. Compound. Let me pull up my PowerPoint too, and I'll go to that slide to help you see it. it's compound plus compound. So here are my options. I mean, these aren't my only options, but these are a lot of my options, okay? Which one of a compound would this be? Is it a metal oxide? Okay, so I can rule pretty much this top one out, can't I? And the bottom one out, because I'm only dealing with water. So my question is it a non-metal oxide or a metal oxide? Non-metal oxide, because nitrogen is non-metal. So we know it's going to make an oxy acid, okay? So how are you going to determine which oxy acid it is? How many O's are there? So which acid do you know has H, N, and 3 O's? Nitric acid. So it would make nitric acid. I will tell you another kind of hint. If things aren't easy to balance, if things aren't that easy to balance, you probably did something wrong, okay? Go ahead. Why is it not? It's an excellent question, okay? Why is it not H2NO3? Because we know it's going to make NO3. NO3 has a minus charge, H has a plus charge, okay? That makes sense to you there? So you know that it's going to make, ignore the H's first, okay? It's going to make NO3. NO3 is a minus charge. In order to be an acid, it's going to have an H with it. So when you cross your charges, we know it's NO3, and we know NO3 is a minus charge. We know H has a plus charge. So it's going to make that, okay? Now, let me do another one. That'll kind of maybe answer this question. What if I go PO3 plus H2O? Same type of thing, okay? Same type of thing. It's a compound plus a compound. So it's a non-metal oxide plus water. It's going to make, because we know there's 4 O's, correct? So it's going to make PO4. And we know PO4 has a 3 minus charge, okay? And H has a plus. Go ahead, Thomas. I'm sorry, I was talking when you were. And then so now I cross my charges, and now it's going to make H3PO4, okay? Now, I'm going to tell you, if you look these up, you're not going to get the same answer. I want you to do it this way now. Okay, I want you to do it this way now. There's some other things in there, but I'm going to give you one exclusively to that. Another one. Let's go with cesium nitrate arrow. Synthesis or decomp? Decomp. So now I'm going to need to go looking through my PowerPoint, my notes. I'm going to go looking through my notes. I'm going to need to find the decomposition reactions, okay? And then once again, that was cesium nitrate. So I'm going to go through here, just scan through here. See, I haven't found a nitrate in there, have I? Still haven't found a nitrate. Still haven't found a nitrate. That's a chlorate, peroxide. Nitrate. So what's the nitrate going to break down into? Oxygen and the nitrite. Oxygen and the nitrite. So it's going to make cesium nitrite plus oxygen, okay? Use your notes. I'm going to repost those notes, okay? Your notes are a resource in this unit especially, okay? I know sometimes we've done some notes, you do them, you haven't really go back and look at them, okay? Excellent things in there. I'm going to call on somebody this time. Let's go with, you might want to give it a shot before I call on somebody. Anybody? Okay, Gavin, look like you won today. I don't know why I'm always calling Gavin all the time. Looks like Gavin's going to win today. Because I believe in you, Gavin. Because I believe in you. MgO plus SO3. Synthesis or decom. Synthesis. So there's more than one reaction, okay? So I agree with that. So now all this is doing is narrowing down kind of where I'm going to look, where I'm going to think, okay? Gavin, how would you describe this? Element plus element, element plus compound, compound plus compound. Compound plus compound. So you're going to go look at the compound plus compound section. How would you describe this compound? So to do this, I'm probably just going to scan real quick for SO3, okay? Because that's my other thing in there, okay? What? The metal oxide plus a salt plus SO3 yields what? Metal sulfate. So what would my metal sulfate be? Yep. Now this one isn't in your notes, but it's going to kind of go along with this, okay? This one isn't in your notes, but you got to go along with this, Aiden. Na2 plus SO2. What's it going to make, Aiden? Na2O plus SO2. If SO3 plus a metal oxide made a sulfate, we know that SO3 has one more O than SO2, so it would have what would have one less O than a sulfate? A sulfite. So what would this metal sulfite be here when I put sodium? So what's the formula for sodium sulfite? Na2 SO3. Does that kind of make sense to you guys? In that, now notice, and this isn't a hard and fast rule, a lot of decomposition reactions are already balanced, okay? Isn't that balanced? Both of those? That's kind of a help with that. Let's go with anybody want to take a stab at it? Yeah, I got 2 minutes to teach. So let's go with Mg. Forget Mg. Let's go with MgO yields what? Decomposition, 100% correct. Okay? Decomposition. How would I describe this decomposition reaction? This is a binary ionic compound, isn't it? Binary means there's 2 elements there. Binary means there's 2 elements there. So what's a binary ionic? And an ionic compound means a metal with a non-metal. A metal with a non-metal. What does a binary ionic compound break down into? Anybody? What's a binary? Man, where am I putting up off it early? You know, I'll put up off it. What's a binary ionic compound break down into? What? I heard the answer over there. Not metal to non-metal. Okay? So, Aaron, I think that's where you were going. Plus O2. Not just O, plus O2, because O is a diatomic element. Okay? Good job. So you have to go, this is how you do it. And now to go balance it, it'd be a 2-2-1 to balance it. Okay? Mg, I do not need a 2 down here. That's a no, okay? Because it's not a diatomic element. Okay? I'll tell you what, on your homework tonight, you don't need to balance them, okay? On your homework tonight, and your homework tonight is a little bit easier than this, okay? I mean, not really. If they're broke down, there's a page of a page of synthesis and a section of decomposition, okay? Predict the product. When I actually predict the product, that's what we're talking about there, okay? I only put a 2. You talking about this 2 right here, Tommy? Wait, it's just MgO because I have no idea. Yeah, Mg2 plus O2 minus, just so. I don't. No, I don't have the homework on paper. I'm sorry. If you want to, I'll print the homework out and bring it. I'll give it to anybody in Miss Burton's class. If you're not in Miss Burton's class next, you come by and see me later. I'll print it out. Paper.
Do they have beef jerky?
I don't know.
Well, if they have beef jerky, I will come in.
Okay, Skittles and beef jerky. Okay.
But I'm not in Miss Burton's class.
Where are you?
In lunch detention.
What's on your lunch schedule? Come on.
A tardy.
Are you Miss Burton's class? Like, going to lunch? No, because you're Miss Burton's class?
Yeah.
I'll take you to lunch. What? You're not come back. You're not Miss Burton's class, are you?
Oh, yeah.
Third.
You got a crusty donut on this day.
Where?
That bad.
Howard.
So, how good is that?
I am. But I couldn't send my message in time. And when I was trying to send it, she caught me.
Hey, no, I'm sorry.
Oh, what you mentioned me? I couldn't see it.
You went out for the blues last second.